Excellent. All right. Hey, folks. My name is Isaac Privatera. I'm a principal scientist in the Generative AI Innovation Center at Amazon Web Services. And today I'm going to be talking about an area I personally find fascinating, which is how do you build a self-improving agentic system? So I'll be talking about the system my team and I built using the open source Strands SDK from Amazon. So it was an SDK our team developed and then open sourced originally coming from in-house, as well as Amazon Bedrock AgentCore, which is our new agentic productionalization tool chain for deploying agents. And I think at this point, clearly everyone is pretty well versed in agentic AI, but just I'll talk about it for like 2 seconds. So obviously, huge step forward for LLMs, giving them agency. Primary components of this are having some kind of memory, tools, reasoning loop, and then giving them goals or tasks that can complete those. We can use those different tools to complete actions with. So we at AWS believe are going to start seeing very large scale propagation of these agents and see them as really a transformative technology. And we're thinking quite a bit about how we facilitate the productionalization of agents in a stable, secure, and scalable manner. So with today's LLMs, it's not really a question anymore of if AI agents are viable. Instead, the discussion has kind of shifted more towards how can AI agents be best put in a position to succeed. And I think this has major implications for how we work. And while I don't think quite yet agents are in a position to fully replace humans, the best workers are going to be those that are able to effectively use AI to improve their productivity. And I think that several reasons why we think that agents are really ready for enterprise use. This is model reasoning capabilities are really as good as they've ever been. Um, Data and knowledge integration has become easier and easier. Now it's very simple to spin up a vector database. We on the AWS side have Amazon Bedrock knowledge bases, very easy to deploy. Also, very excited to see the infrastructure and especially the protocols. So the maturity of MCP, A to A. These are huge factors. And then as well as, a lot of great folks here who have been developing agentic tools. I think the set of tools that are available are really mature and it's really great to see. And I think that this all together makes AI agents much more viable than they were, let's say, even a year ago. Um, and also just to set the stage in terms of where we came from versus where we are now, guys are probably familiar with robotic process automation, entirely rules-based and just executed with predefined flows. Then 2023, 2024, era of RAG chatbots, generative AI assistants, the ability to kind of go through a RAG database and answer questions. And I think right now we're in tier three, which is where we're seeing the propagation of kind of goal-driven agents. They're able to independently execute tasks. You can have multi-agent systems where they're able to work together towards a goal, but we're not quite yet at this fourth tier, which we would say is kind of fully autonomous agentic systems. That being said, if you asked me, even like a year and a half ago, if I thought that AI agents were ready for prime time, I would have absolutely told you no, because the consistency of the LLMs at the time were just not good enough. Uh, Now we're seeing LLMs with substantially lower hallucination rates and greater accuracy. But that being said, the hallucination rates, even for the top LLMs, is not zero. And we'll talk later about ways we can kind of address and look at ways to evaluate. And another thing I just want to state is that, agentic AI, not a magic wand. Um, it has really impressive capabilities, and it's really powerful. But you need to be careful to carefully tune your prompts and your tool definitions. And even when your prompts are tuned as well as possible, you still will likely see some mistakes in really complex tasks. And this is why human in the loop is a critical component to the success of AI agents. And I think, it helps to think carefully about what granularity you want your tool definitions to exist at. So they could be very granular if you need a lot of flexibility in the task. But if something, something I like to say is that if something was a directional acyclic graph or a DAG before, there's not really a reason to insert an agent into the middle of it. However, you could have an agent control and execute that DAG. So I think that there's different ways in which you can implement tools. So it just makes sense to think carefully about what the best way for you to implement tools for your use case is. Um, And just generally, I think there's a lot of different considerations for the way you implement agents, um, latency implications, cost implications, complexity. Do you need to be able to have human in the loop? Do you have task execution stopping mid execution? So, number of different things to think about. But generally, you want them to use agents where there are tasks that are require flexibility. So, just talking about the agentic loop, as I mentioned before, create an agent LLM, but providing it with memory, tools, um, goals, giving it goals to achieve, and then allowing it to reason. And then the flow for this reasoning can vary, but the dominant agentic reasoning paradigm right now is React. So the loop starts with a user interaction, agent will receive the input, then decide what action to take next. So it'll determine if any tools are needed, and then answer the question. So this can be single, multi-step, and after each LLM, each time the LLM reasons, it's about its previous action. It'll look and see if that was successful, and then decide if it needs to proceed or stop. And something I like to talk about is just because I think React is the dominant paradigm right now, but there are other paradigms that do exist. And I think it's valuable for us to know about these just because there's different times in which they may make more sense. Um, so React was first introduced in 2023 by Yao et al. Paper React, Synergizing Reasoning and Acting Language Models. And I've kind of mentioned this already. It just combines reasoning and acting to create the agentic loop. It does tend to be the default with pretty much all different agentic development kits. Agent's going to be given a task, we'll reason about how to accomplish it, and then we'll begin calling tools and reason after each action. Rewoo is an interesting one in that the agent generates a plan and then executes it, but not actually the intermediate routes. So it will just kind of create this step-by-step execution plan, and then we'll just start executing until the answer or gets the answer, and then you can restart execution once it's done. And then there's also reflection, which is another interesting one, which promotes self-reflection and iterative refinement. However, this self-refinement can introduce some latency. So it's not always the best choice for consumer-facing applications, but it is an interesting one, especially for kind of like thinking about like deep research, for example, things where you don't necessarily have these latency bounds. All right. And another concept that we can kind of talk about, we've already talked about agentic reasoning. So now we can talk a little bit about when does it make sense to use single versus multi-agent. Single agents tend to be pretty capable, especially with the new top of the line LLMs that are out there. But the more that we expand the scope of our agents, the more likely they are to make mistakes. So for the most complex tasks and goals, it can be a good idea to let agents specialize in specific areas. If we provide an agent with like, let's say, 50 tools, 100 tools, it's going to be more and more difficult for a single agent to know when to use all of those tools. And also the thing to consider is that when we have all these different tool definitions, those are all going to wind up in its prompt. And so if you have 100 different tool definitions that need to wind up in a prompt, that's going to make it balloon in size. So it's not exactly the most efficient to necessarily give it that access. There's different ways you can also address this via semantic search with tools, but generally I like to have agents specialize in kind of these multi-agent systems. So talk a little bit about multi-agent patterns. So these are two probably the most common patterns, which are agentic swarms and then supervisor subagent. There's more patterns than this, obviously, but these are two of the most common. And the difference between these two patterns is while in supervisor subagent, the supervisor controls all of the routing and the final decision making, swarm is a little bit more collaborative. So each agent in a swarm has awareness of the other agents and thinks about when to hand off. Supervisor subagent is a little bit more structured. And also probably it scales better because you're having the supervisor focus on which agents to go and in what sequence. That being said, there are advantages to using a swarm. The awareness of other agents within the swarm can actually be an advantage to prevent duplicate work, just because if, let's say, there is some tool overlap between them, then because all the other agents, the agent within the swarm is aware of all the other agents that sit in its ecosystem, whereas it's on the supervisor to inform the other subagents of what was done previously. So there's definitely ways in which both of them make sense. I think as you scale, in particular, supervisor subagent makes more sense, but swarm patterns definitely can be pretty useful. And I think there's also hybrid patterns, or there's hybrid patterns as well. So, think of like supervisor that could hand off to a research swarm. Uh, Not necessarily going to talk too much about that here, but there's also competitive patterns. So think about like agentic arbitrage. You have like two agents that are trying to negotiate. In our solution, we used a supervisor subagent paradigm, but tons of different ways in which you can implement, and would just recommend to test and try as many as possible and just think about which ones make the most sense. So I mentioned it before. We open sourced our Strands SDK, which is our agentic SDK for that we use internally at Amazon. Basically, what we wanted to do is develop something that was simple, streamlined, and model driven. So the idea is it's easy to use, very intuitive, got strong capabilities. MCP integration, native integrated with AWS services, um, also very easy for prototyping. And so we use this a lot. That being said, you can use whatever framework you want within Amazon Bedrock. Um, for Strands in particular, the way it works is it's built on this agentic loop, which by default React. But there are ways to do custom implementations for different types of custom agentic orchestration. So, with any standard agentic loop, it receive user input, process it, decide what to do, generate a response, and then kind of continue that loop iteratively. So, talked about strands. Now we'll talk a little bit about something that we at AWS see quite a bit with all of our customers is um, it's pretty easy to get one agent out there and just have it running locally, but scaling can be a real challenge. And so what and especially when you think about the number of ways agents need to communicate and how you manage agents at scale. So right now, if you have your agent, um, and it has access to its tools. How do you scope that at the department level, organization level? How do you decide what agents are able to communicate externally? And especially this problem only gets worse as agents continue to propagate. And so it's definitely something that is can be pretty challenging. And I think that, when you're trying to implement all of these things at production scale, then all of a sudden you need to think about how am I monitoring performance? How is my system scaling? Are my systems or are my agents secure? How am I governing my agents? So these are all really complex questions, and I think it actually is something that doesn't get addressed quite enough, especially when people just kind of go grab some agentic example off the internet and start implementing it. That's pretty easy. Actually, deploying all this stuff and getting it to run in prod, much more difficult. Um, so that was the motivation for us to launch Amazon Bedrock AgentCore. So the idea for AgentCore is it's our agent or agentic deployment tool chain. So it has components for agentic runtimes, memory, tool hosting, identity, and observability. And the idea is that we wanted to kind of handle a lot of the undifferentiated heavy lifting when it came to deploying agents, particularly at scale. Currently, the service is in preview, but it's going to be launched soon. And so the idea is that because you can build whatever you want using AWS or any other cloud infrastructure, but I think that there's certain problems you may run into that tend to be fairly persistent. One is, let's say, for your runtime, if you want to be using some kind of serverless solution, timeouts tend to be an issue if you're doing some kind of deep research project, or figuring out how to do kind of bidirectional streaming. These are problems that you'll run into as you go into prod. And so that was one of the goals of AgentCore, is to be able to solve a lot of these problems and remove that undifferentiated heavy lifting. So for folks who may not be as familiar, can just show you guys kind of what the AWS agentic stack looks like. For folks who are not familiar, Amazon Bedrock is our overall generative AI service. So this includes pure model hosting, serving, but also a number of other different abstractions. So we have optimization, model customization, guardrails, knowledge bases, which are effectively kind of a managed vector database. Um, we also have AgentCore now, which provides AgentCore runtime, gateway, memory, identity, observability, and a few first-party tools as well. But we also have plenty at the infrastructure layer. So these all work together. And then we also have Kiro, which is our agentic coding IDE. Won't be talking too much about that one, but that one is interesting, so it is definitely worth a look. And then we also have Nova Act, which is more of our browser use toolkit. So that's another thing that you can use where you can either have that run on its own or you can use that as a tool for different kinds of browser use, computer use workloads. And then also Strands agents. But one thing I'll say is that, AgentCore and all of this is designed to work with whatever framework you want. So there's nothing stopping you from using any model, any framework. If you want to use OpenAI models, there's no issue deploying that on AgentCore. We have no restrictions on kind of what you can do there. It's effectively the same as just using a Lambda. Um, so just double clicking a little bit on AgentCore. So I mentioned kind of some different components here. And our solution is built using all these components, particularly the runtime is for hosting everything. So this is where you specify all of the components like your agent instructions, your context, your tools, and then whatever framework you want. It's pretty much agnostic. If it can work within a Docker container, it can be deployed on runtime. Then we have some of the other ancillary services here. So like AgentCore Gateway. So this is, you can kind of think of it as an MCP gateway. So you can have your tools effectively made as gateway targets. And then the gateway will manage access to these tools. So that way you're able to have your agents use different tools from the gateway, also run semantic search over your tools. So you can run semantic search for all the different tool definitions. So if you want to, you can just make a call to the AgentCore Gateway API via Boto 3, or we have several other APIs and SDKs that you can make that call and then just semantically retrieve only the tools that you want. Couple other first party tools that we have as well. We didn't use them in this solution, but they are interesting and definitely worth a look. Is we have the AgentCore browser, which is a managed browser use solution. So it will it'll help launch browser use workloads in a secure, isolated environment. So we'll use launch Chromium for you. You can do it either headless or you can do it where you're actually able to kind of view what the agent is doing. And we also have an Agentic or AgentCore code interpreter. So for both of these are just workloads that potentially have more kind of security implications with them, especially just having something have access to a browser, being able to just launch and execute code arbitrarily. So we wanted to make sure that these were environments where they were secure and isolated, and that you can kind of send instructions to them, but it doesn't just have like open access to any tool or system. Then we have AgentCore Identity. This is not one of the more I guess, sexy, if you will, services, but it's a really fundamental one. It's a really important one. So the ability to authenticate and have tokens for your agents, not only to communicate internally, but also externally to external APIs. This is something that I think is really, really fundamental for anyone who's building agents. So this is one that I think is really important. So identity is one that we built in to the solution. Also, we have AgentCore memory. So memory works on a couple different levels. So there's short-term memory, which is kind of your standard just state saving text, as well as long-term memory abstractions. So we have user preference memory. So this is effectively looking at your conversations and extracting different user preference details out of them and then saving them to a database. And then also we have long-term summarization, and you can implement your own kind of custom memory implementation that you want that will effectively just kind of operate over this long-term memory. And then finally, but arguably one of the most important pieces and something that's really critical to the application we put together is AgentCore observability. So AgentCore observability is built in. So it's not necessarily, you don't have to use runtime in order to use AgentCore observability. And I think that's something that should mention about all of these is they're designed to be modular. So you can use them with kind of any one of, or just one on its own, use them all together. Obviously, they're designed to be interop very easily to work together interoperably, but you can just kind of pick and choose which ones you want to use. So if you just want to use memory, you can just use memory, no problem there. Or if you just want to use identity, you can also do that as well. And so for agent core observability, this is built in for runtime. So any agent you deploy um, on agent core runtime is automatically going to be logged agent core observability. So you'll be able to look at your traces there. And so that's a pretty important part of kind of the system that we put together. And then just a little bit more on what runtime does. I won't spend too much more time on this, but effectively, the idea is that you have your models, whatever model you want to use, whichever framework you want to use. You just add your runtime decorator, your identity config, and then you can configure what kind of observability depth you want, and then configure it, create a Docker file, or we have a starter kit that will create a Docker file for you. Then launch, and then what we'll do is it'll have that Docker image hosted in our Elastic Container Registry. And then we have the concept of an agent as well as an endpoint. So an endpoint is a specific deployment of that agent, but the agent is kind of the larger abstraction. And then agent core observability. So this is just kind of your standard tracing. So everything you would expect with tracing framework, you'll be able to find here. And so you can, as I mentioned before, agents deployed on agent core runtime work, or agents running outside of agent core runtime work as well. So I think there's some interesting concepts when it comes to evaluation. There's two kind of main feedback paradigms. One is offline evaluation. So this is pretty standard. This is your standard eval metrics. Think like success rate. Think like tool call accuracy. Like these are things that are straightforward to implement. And they can just be run at will. So like you can integrate it with your Jenkins pipeline. Whenever you maybe make a change to your code, you can have your offline evals run. And I think it's a really important thing to implement, and definitely something you want to have a mature pipeline for. Um, Online evaluation, I would argue, is almost, I'd actually say it's more important just because when you think about offline versus online, offline is really helpful in terms of like giving that guidance in terms of directionally. But online, when you're looking at your actual feedback from your users, this is incredibly valuable information. It can come in different forms, but fundamentally, I think it's really important to have some kind of pipeline where you're actively looking at your traces and then looking at especially the feedback you're getting from users, or you getting like thumbs up, thumbs down, what kind of comments are they leaving. And then also I think another thing that's really interesting and very valuable to look at is that implicit feedback. That implicit feedback can mean something like just leaving the chat early when unexpected. And I think there's different ways to kind of look into this, but it's definitely something that I think is really bears some emphasis. So next, let's just talk a little bit about some of the different metrics. So I'll go back to offline. So I think for agentic evaluation, some different things that I like to look at are tool calling evaluation, final response, and then also kind of operational evaluations as well. So for tool calling, just kind of assessing the appropriateness of the tools, and this is kind of on a per agent basis. I think you can also kind of like roll these up for your multi-agent system as well. But just looking at, incorrect tools, missing tools, tool argument accuracy, weighted averages of these, and then looking at tool calling accuracy with LLM as a judge. And one of the things that I like about with tool calling, and in particular with this offline tool calling evaluation, is if you have the tool that for a query, it's deterministic, which sometimes like LLM as a judge is really effective, but I think it helps to have those different types of metrics mixed in where you can have some that are deterministic, some that are LLM as a judge based. So I like to have a good balance. Just because it makes it a little easier, or I think it's a little gives you a better view of your overall accuracy. Um, it definitely helps in terms of, reasoning, multi-step actions, long-term coherence, and then talk a little bit about kind of response evaluation metrics. So these are ones you've definitely seen before if you've implemented any kind of offline evaluation: correctness, similarity, precision, recall, relevancy. So these are pretty standard. I think most libraries you can find these. Um, Online, coming back to online metrics, these are ones tend to be a little trickier because they often, well, you're not going to have ground truth with these. So I think that analyzing this data is something that is really, really valuable for anyone who's got like large scale agentic deployments because there's quite a bit of information within those traces. And I think the thumbs up, thumbs down feedback is really, really useful, and it's the most common implementation just due to simplicity. Personally, I'm definitely a bigger fan of Likert scale feedback over thumbs up, thumbs down. But the problem is that if you're asking a user to give a star of like 1 to 5 stars, a lot of times they'll just kind of like eyes will glaze over and just when they're trying to think about, well, do I think this is 1 to 5, and then just not answer. So thumbs up, thumbs down, even though I prefer the metrics you're able to calculate with Likert score, um, you're just going to get less engagement of that actual metric. So for that reason, my go-to tends to be thumbs up, thumbs down, even though there's more information and more that you can derive from Likert scale. Um, then, comments obviously are really valuable, but that's going to be a very small percentage of your users that are actually going to take the time to write a comment. So, like for online metrics, it definitely makes sense to have a pipeline for evaluating these comments. But I think it's definitely going to be a subset of your users that are going to actually use these comments or are going to leave comments at all. Then also there's some other implicit ones as well. Latency obviously is pretty easy to measure. Path efficiency is an interesting one. So path efficiency is one where even if the LLM got the correct answer and the user was happy, did the LLM kind of take unnecessary steps? And did the agent take unnecessary steps in getting to that answer? So that's one that I think is definitely valuable to look at. Abandonment rate. So if your users kind of are leaving mid-conversation, and then question repetition, these are ones where you have to actually spend some time figuring out a pipeline of how to tag your traces. And I think that especially as it gets larger and larger, like if your application has thousands or hundreds of thousands of users, that's where I think it bears a lot of thought in terms of how you're going to implement this pipeline. But there's a tremendous amount of information that you can retrieve uh, if you can kind of build this pipeline up. So now this is the actual architecture of what my team and I put together. So this is this kind of like self-improving agent concept. Fundamentally, it's just a multi-agent system where we have a supervisor, then we have 4 different agents. In this case, we were just using fairly simple tool set, although one tool is a little bit more complex, and you'll see why. So the main idea is it's kind of like a travel assistant, but it's also got a shopping component mixed in because it uses the Amazon product advertising API, which has access to the entire Amazon product catalog. So you're able to ask travel questions, search the internet, or ask for recommendations for different products that would make sense for like your travel. So in this case, there's 2 agents that are dedicated to that. One is a shopping assistant. So this is the one that actually controls the access to those APIs. And then there's a cart manager that is just dedicated to kind of managing, removing, or adding items to your cart. Um, and so these are, it's a fairly straightforward implementation in terms of kind of the main piece, just using strands, using a setup with a supervisor. The agents are set up as tools for the supervisor. And then each one of the agents has access to its tools, which are deployed MCP servers. Then the thing that I think is probably the most interesting here is the analysis agent on the right-hand side. So the analysis agent is set up so that it will be able to look and analyze traces. It also takes in the prompts and has an understanding of the system architecture. So what you're able to do is you're able to pass all this information to the analysis agent. Then the analysis agent is able to assess through these traces and through the prompts, what changes need to be made, what are kind of common errors, and what are the things that need to be changed to improve the performance of the system. And so you can implement this in an automated way. What we did is we set it up so that it would return those recommendations, which the user can then implement, but pretty straightforward to do on your own. And just to give you guys an idea of kind of what this looks like, here you can see this is kind of current instruction. So this is the shopping agent. This was its existing prompt. This was the recommended adjustments, as well as also it will look at tool definitions and say, oh, this tool definition needs to be a little bit more robust, or maybe even you should consider taking this tool and moving it over to a different agent. All right. And so with that, we'll jump into the demo. So here, let me jump over here. Just a simple React front end, nothing too crazy. But let's just start by just kind of showing what it does. So here you can see we have just this our supervisor agent, which is kind of answering our questions. But there's a couple other different wrinkles here within this UI. So we have profile information that we're storing that can kind of dynamically be adjusted here, as well as we have a shopping cart. Um, so let's go ahead and start with a simple question just to start off. Oh, and then also, I think another important piece is the ability to provide feedback. So what we did is all the feedback goes to a Dynamo. I cleared this out because it was kind of large, but all the feedback goes to a DynamoDB table. So you can see kind of the feedback, any comments that you get stored here, and then can be pulled by the agent when it's running its cycle. So here we go. This is some information about Bali. So in this case, you could see that when the supervisor was given the prompt, different from the initial question, it then goes to look for the previous or the travel agent. But now let's go and run something using the Amazon Product Advertising API. So here now we can see it's calling a different agent. So it's now using the shopping assistant. So previously it was using the travel assistant. And so now it's running searches over the Amazon product catalog kind of while it's doing this. And one of the things that we need to do is we need to implement sub-agent streaming. Uh, but so in the meantime, what I can do is I can kind of show you guys what this looks like within Amazon Bedrock AgentCore. So within Bedrock AgentCore, this is the console. So you can see these are the different components here. So we have the runtime. So this is where we have our agent deployed here. So you can see the last time it was updated. So when you click on an agent, this will show you, how you can invoke it using TypeScript, JavaScript, or Python. And this also shows you all of your different versions as well as your endpoints. In this case, I just have one endpoint up and running, and that's what we're invoking right now. Jump back over here. Um, Taking a little bit longer. It's probably running multiple searches. But anyway, what we can also do is we can, within a given agent, look at the observability. So here I can go into any agent that's deployed within AgentCore. I can go look and see, how many agents I have, how many sessions I have, what's kind of my traces, my error rates, all of these kind of standard metrics. And then I can jump into a specific agent, go look at traces. So here we can see, and this is just kind of just like standard trace metrics, looking at, what happened each time. Also like all of the different components in terms of like what was actually run using AgentCore. So then here we've finally got our answer. So in this case, we can see it's recommending a few different things. So top recommendation, go take a look here. So it looks like some decent sunglasses. Then to kind of round it out, what we can do is we can then say, please add the Oakley sunglasses to my cart. Oh, I think I should probably specify cables. And so then what it'll do is it will engage the cart manager assistant. And so then it will go take a look at my cart. In this case, the cart is DynamoDB. There are ways that you can do kind of an add to cart button from using. And by the way, the thing that we're using here is this Amazon Product Advertising API. So this is something that you can get access to depending if you're like with an Amazon seller. Um, but overall, the idea is that you're able to kind of use these different subagents. So I think what I'll do, looks like there was an issue here, but just to kind of jump back over, so to show you guys what the analysis agent looks like, because that one takes the longest, just because it's got to pull in a lot of different traces, all the different prompts, all the tool definitions. So here, this is one that I ran earlier. So kind of analyze the system performance, give me prompt recommendations. Um, so here it's kind of looking at response times, usage statistics, prompt recommendations as well. And then here some system recommendations. Current sequential model creates bottlenecks. Um, Implement, optimize internet search. But then also here, you can ask it for more direct kind of prompt recommendations. So this is the updated prompt it thinks you should use, using some of those recommendations it had previously, as well as so for all the different agents kind of implementing and then understanding from the tool definitions kind of what structure all the data comes in for the product advertising API. Same thing for the cart manager, and then as well as the actual supervisor agent itself. And then you can kind of double click on different trends and things that it noticed. So in effective, it's kind of like a way to talk to your traces. But the idea is that you're able to pull all this different information, and then actually use it to get some actionable recommendations for how to improve your system. And we were able to see some pretty substantial improvements in terms of going from like uh, the base prompts that we had to more robust prompts. And so I think that this is something that we want to try to implement more robustly and at scale. So with that, I'm going to jump back over to the presentation. Jump out of this. So in terms of recommendations for implementation, the example provided is kind of like a toy example. At scale, you need a more robust search mechanism to identify relevant traces. So I think that this is where it makes sense to do some kind of tagging on your traces. So because if you're using like a top end model to analyze 100,000 traces, it's going to cost you a lot of money. So it's something where um, makes more sense to start with a smaller model to do some analysis and to effectively kind of add tags and then look for and do kind of filtering on those tags to do a more robust analysis. In our version, we didn't implement automatic prompt optimization, but pretty straightforward to deploy that. Just effectively need to give it access to the actual repo wherever your prompts live, whether that's in GitHub we have Bedrock prompt management as well, or whatever prompt repository you're using, just giving it access to that. And then I think just generally speaking, the standardized analysis of your user traces is something that I think is really important for pretty much every production application. And I think it's something that it's a pipeline that offline evaluation pipelines tend to be really robust. I believe online evaluation pipelines should be just as, if not more robust. And then in terms of examples, we have plenty of examples to get started with for Amazon Bedrock AgentCore if you're interested. These are very easy to use, and we have integrations with a number of different LLM agentic frameworks, so you can go and get started and go play around. And that is pretty much it. So can address any questions now that folks have. Okay, yeah. So there's some interesting questions here. I see one. Can you enable the agentic workflow to decide on its own on the type of agentic reasoning strategy used based on the specific use case? Yes. So this is an area that I've definitely been looking into, and I think that there's ways in which you could kind of either put some kind of like small LLM that just is making a really quick decision about like, is this low, high, or medium? Um, or you can put like have the LLM kind of like make that judgment call. The thing is, in order to do that, you really just need to make sure that you're optimizing that call and have it using as few tokens as possible, just because otherwise you're going to be adding additional latency to trying to do um, dynamic reasoning. Um, and then, yes, happy to share the presentation. Um, can follow up on we do have a free tier. I think that also we have one thing I will say is the we do have Amazon Nova models. Those are priced very competitively. So if you want to kind of run experimentation with those are a pretty good way to save money. Let's see. So in terms of business metrics, I would say I would just look at kind of typical metrics, like thinking about like marketing metrics, for example. Like if you have like a retail system, thinking about like how do I calculate like lift, for example. Those are like pretty well established metrics. It's just kind of tying those back in to the LLM and the agentic performance. So that can be take some creativity, but I think like there's a lot of like really standard fundamental metrics that exist that you just need to figure out how do I take the data that's generated from my agent and my agent interactions and kind of tie this back. Just look at how that interaction's happening. Um, so AgentCore is effectively like Lambda. It's like serverless. So under the hood, it is using EC2, but the idea is that you don't have to manage anything. So the whole concept of AgentCore is it's all serverless. So nothing is going to be something you have to manage. It's going to just handle all those different pieces on its own, and then just you'll just effectively call it, and then you're only billed as you use it. So EC2, like if you are hosting an LLM server on EC2, you're going to be paying for every second that's up. Versus Agent Core, you're only paying on a per invocation basis, very similar to Lambda. All right, let's see. What are these type of agentic agents now commercialized by businesses? We're starting to see that, at least from my perspective. We've started to see some customers actually moving these to production. I think they're pretty nascent. In general, I'm not seeing like there are. I think probably the places that are having like that have like the most robust deployments are kind of ISVs or the software vendors. Um, there are some retailers though that are launching them. I think we're starting to see them in terms of the actual capabilities they're being given. I think that people are or companies are being a little on the conservative side, which totally makes sense given that I think only recently has MCP started to become more secure and have the security vulnerabilities been addressed. And that's something that we as AWS are spending a lot of time kind of thinking about, and one of the reasons why we really wanted to make sure that we put in some kind of identity piece to Agent Core. Let's see. If I'm using memory from a third-party platform provider, can I integrate their observability metrics in Agent Core? So within the runtime, you can call whatever API you want. So as long as they have an API within the runtime, then you can pull that data in. So difference between Agent Core and Lambda. So Agent Core Lambda has a 15-minute timeout is one of the main things. Agent Core runtime is designed to have an 8-hour timeout. So it can do much longer jobs. So any kind of deep research, as well as it's also configured for streaming. It's also, there's no limit on payload size, which you might find with Lambda. And also it's actually priced a little bit differently. It's more competitive for agents. So when, for example, you're running like a multi-agent flow and you have different nodes or different runtimes running, then what can happen is with Lambda, you'd pay for that entire process versus when you have everything deployed on AgentCore runtime, those individual runtimes, you're just paying for the actual time the agent was invoked. All right. Well, want to be respectful. I don't know if I'm out of time here. I think my session officially has ended.
Isaac, if there are any questions, please feel free to take those.
Okay, great.
Yeah,
Great.
and you may take maybe 5 more minutes. Yeah, that should be okay.
Okay, great. Happy to do that. Um, yeah, so I think for good, I think deep research is probably one where like using these really high level reasoning models makes sense. It's just tough to use some of the high reasoning capabilities. When literally what I'm talking about is for most of these models now, they tend to have different settings like low, medium, and high reasoning. Setting that high reasoning is going to make the output pretty verbose. So you're going to get a lot of intermediate tokens. For something where it's not latency sensitive, that definitely makes sense. Um, and so I think that it just depends on like kind of what kind of application you have. Um, yeah, I don't think there may not be a free tier for Bedrock, but what I would say is generally speaking, as I mentioned, kind of the Nova models are um, pretty competitively priced. So Bedrock itself is just a generative AI service. Oh man, I love all these questions. I wish I could answer every single one of them. Okay. Let's go back up. So what is special about Bedrock in terms of agentic AI? So Bedrock fundamentally is like, so there's different abstractions. There's Bedrock, and maybe let me go back to the stack actually. That might be helpful. Sure. Yeah, so Bedrock is kind of a suite of different services here. So you can see that we have like the base kind of models. That's just the serving. So that's all the different models we have available. Oh, also, by the way, we do actually have the OpenAI OSS models, which are also very, very competitively priced. So I would check those out as well. Those are really powerful and have the different reasoning capabilities as well. Then within Bedrock, there's different components. AgentCore is specifically a piece of Bedrock that is designed for agents. So that's kind of the main agentic piece that we are emphasizing. And then we have our Strands SDK, as I mentioned, but you can use whatever framework you want. So there's no restriction on if you're, more of like Crew AI, LangGraph, that is your preference. You can totally use that with AgentCore runtime as well. So in terms of the reasoning why it's verbose for high, it's just because it you're instructing it to think carefully about what it's going to do. So its reasoning process is basically just printing out a whole bunch of tokens and kind of like thinking out loud effectively. So you're just making it think quite a bit, and then that's going to make it more verbose. Versus low, it's going to output a much lower number of tokens. Um, so in terms of, I think, would it be overkill to set up a single agent with Bedrock Agent Core? Definitely not. I mean, if you would deploy a single agent on Lambda, you could do the same thing with Agent Core. Um, And then I see another question I really like. Multi-agent setup reminds me with microservices. Do they work together implementation wise? So this is actually another project that we're working on. Because one of the things that I think that we see is a lot of these multi-agent systems are deployed as a monolith where you have all the different agents on the same compute. A more realistic scenario is actually having each agent run as its own microservice and then communicating kind of like A to A style. So that is something that I think that we want to we're looking into more kind of common deployments for that. Let's see. Am I out of time, Roger? I just helped more time.
So Isaac, please feel free to take. Since the audience is engaged, I think you can take a few more minutes.
Okay. Um, and some of these I'm happy to take offline. I'm not a security expert, so if it seems like I just want to make sure I'm getting the correct answers on some of these. So I would want to get back to you folks on some of those. Yeah, so I think in terms of how to make sure these agents are not overkilling the process, um, yeah, so that was actually under the hood. That was a I got throttled. We actually have lower limits as AWS employees than we give to customers. But the effectively it's the way I kind of think about it is kind of similar to security. Um, with each like sub agent, it's just kind of like least number of tools it needs and least amount of kind of context it needs. And I think probably I'm sure this got mentioned earlier, but I really like the concept of context engineering. So thinking carefully about like how to manage that context is going to definitely help. Um, so it's and one thing I'll also say, you don't necessarily need to use agents for everything. So you can use like workflows if something's more simple and just needs a couple like directional like pieces of information, and you don't need that flexibility. You don't necessarily need to use agents. But I think that for something more complex, where there is a lot of reasoning that needs to go into it, and then there's multiple different paths. Also, you want error correction. That's where a workflow kind of falls apart. Versus like and because you can only have so many branching trees before the logic just gets too complex to manage. Agentic framework you shared conforms to the Amazon native framework. So if the client wants the solution to be running on other cloud platform, how much would the additional effort be? So there's different uh, within the Strands framework, you can use different model providers. There's not necessarily a restriction on using just Amazon Bedrock. I think the integrations are going to be the best with Bedrock, but we have integrations for all kinds of different model providers. Yeah, so you can use your own MCP server as a target for AgentCore. So that's definitely something within. I would take a look at AgentCore Gateway. Let's see. Trying to see what other questions I've missed. Yeah, so if you look for in terms of the trust model, I would go take a look at the AgentCore identity documentation. So each one the and actually maybe I have a slide that I can share here, although I don't think I have probably don't have that handy, unfortunately. But I would go take a look at the documentation and we can pass some links there. Well, I unfortunately have to run, but thank you so much. I'm really happy to see all the questions from the audience. These are great questions. And for folks whose questions I wasn't able to answer, I will try to see if I can find an answer and then post something on LinkedIn.
Thank you so much, Isaac. It, Really, there was a lot of engagement, so thank you so much.
Thanks, everyone.
Thank you.